Hello, in this video I solved the second question in the problem set number 1. Let us read the question first. Is the function d defined on R Cartesian product R to R defined by dx and y equals to square root of absolute value of x minus y a metric on R? Motivate your answer. The answer to this question is yes. We actually showed that this function satisfies all four properties that we expect for a metric. Okay, so for example, for the first part, I would say that let x and y be real numbers. Okay, I have chosen x and y arbitrary real numbers. Then dx and y is equal to square root of absolute value of x minus y, which is clearly a non-negative number. So the output is a non-negative real number. So number 2, let us say x and y are in R. Okay, and then we know that dx and y is equal to 0. So this happens if and only if square root of absolute value of x minus y becomes 0, but this also happens if and only if absolute value of x minus y is equal to 0, and this happens if and only if x is equal to y. So the second one is also satisfied. Number 3, let us assume that x and y are real numbers. But now dx and y is equal to square root of absolute value of x minus y, but then dy and x is equal to square root of absolute value of y minus x. But from the properties of the absolute value, we know that this number and that number are exactly the same. So their squares are also, square roots are also the same. So we realize that for every choice of x and y in the set of real numbers, dx and y is equal to dy and x. And this proves the symmetry. Finally, we need to show that this satisfies the triangle inequality. So I would say that let x, y, and z be real numbers. Okay, our goal is to show that the distance from x to z is less than or equal to the distance from x to y plus d, the distance from y to z. So this is our question mark. We have to show that. Okay, but one technique in proving inequalities is to write the inequality and simplify it in a recursive way, in a reversible way, sorry, not recursive, in a reversible way, so that I can come up with an inequality which is guaranteed to be true. So the first thing that I would do, I will translate this generic triangular inequality using the formula given for the metric. So this is equivalent. So I would say that the question mark here that I am seeing if I can prove it or not is equivalent to saying that square root of absolute value of x minus z is less than or equal to the square root of absolute value of x minus y plus square root of absolute value of y minus z. Okay, but this, because all these terms are non-negative numbers, this is equivalent if I raise this inequality to power 2 on each side. So this, the left hand side becomes absolute value of x minus z. The right hand side becomes the first one squared, which is x minus y absolute value, plus the second one squared, which is absolute value of y minus z, but of course plus 2 times the first one times the second one. So this becomes 2 times the first one times the second one. Okay, so what I have shown that this inequality, which I am supposed to prove, and I called it the question mark, is equivalent to this inequality. That's not surprise because I just used the definition. But because this is non-negative, this is non-negative, this is non-negative, this means that the right hand side is totally non-negative and the left hand side is non-negative. So there is no difference between saying this number is less than or equal to this number or saying that the square of this number is less than or equal to square of this number. Okay, so you see that this arrow is double-sided. But this inequality, I can be sure that it is true. Why is that? Because if you go and watch the lectures, in the lectures I showed that the absolute value of x minus z is less than or equal to the absolute value of x minus y. By the way, that was the proof that the Euclidean metric, the usual metric on R, is a metric. So that was the inequality there. So if you see the lectures, we prove this inequality is true. Okay, so this means that this expression is smaller than this part, but this is also non-negative. Okay, so the situation is even better for us because this one is smaller than this part, let alone if I add something non-negative to the right hand side. Because this is true, I know that this is true, and because this longer one is equivalent to this one and this one is equivalent to my question mark, then I have proven that the question mark is also true. Okay, so this function actually satisfies all four properties demanded for a metric. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.